I'll stand up in 5 minutes.
All right, thank you. Is this thing on? Yeah, you guys can hear me? All right. Well, it's a pleasure to be here. Right now, I currently reside in southern Pennsylvania, about an hour north of my home place in western Maryland where I grew up. So I'm a weekend farmer, right? I guess I have like the best of both worlds. As Ray said, a couple of years ago, I was the extension forage crop specialist for Penn State, covered the entire state of Pennsylvania on all things forage crops, really grew my knowledge in terms of dairy production. So that was a great opportunity for me where I grew up on a cow-calf operation. Both of my graduate degrees were focusing on stocker calf operation. So I felt like I got a good balance in terms of beef cattle knowledge. And then my next position was with Penn State, and then I got to learn all about dairy cattle management. So whenever I got hired with AGCO, I was actually their first animal scientist that they had on staff, and I still remain that only person with the term livestock in their title. So what my position is, and the reason that I'm telling you this, I'm getting to the point, but what my position is I work in product management, and I am really the bridge between our engineers, that we are in green harvest, that's what we call it, that's our forage equipment, product management. So I cover so we have product managers for each of our individual hay tools, for our windrowers, for our pull-type mowers, for our small square and large square balers, for our round balers, etc. So we have product managers for each of those, and then I am kind of the umbrella over all of those products. And I help to consult those product managers on why our machines need to do certain things. And then I go back to our engineers and talk to them about what our machines need to do for you. And then I also work with marketing. So with marketing, we're talking about the machines that are already on the market and are available for you to purchase. So then we conduct field trials, agronomic field trials. We're also doing some livestock nutrition trials this year. So we can see what our machines that are already available on the market are doing in terms of in the field and in the animal. So at any point today, my job is to go back and talk to our engineers about what we as an agricultural equipment company can do for you. What are your problems? Is your hay not drying down fast enough? I was on a farm visit last week in Washington. One of our larger customers that we have up there, a large square baler customer, and I was talking to him, I was asking him, what can I tell our engineers of a way that's one thing that's going to help your bottom line and that's going to make your life easier? And he said, make my hay dry down faster. And so we continuously are working on that. I have some things to share with you today about that exact thing. And then we also have some fun things in the pipeline that hopefully you'll be seeing in a couple of years to help you dry your hay down faster. And so I'm going to start out today talking about mowing and conditioning. Probably if we had thought this through, I should have done my other one first because it really lines up with what Chris talked about, and I have a lot of the same slides of what he talked about. So keep tucked under your hat what he talked about earlier because this afternoon we're going to revisit a lot of that. But let's talk about mowing to start off with. And so also at the end or throughout this presentation, I also have some stuff in there about tedding, and then I also threw a little raking project that we did last year, just because I like to share some of the data that we're doing at AGCO and at Massey Ferguson specifically. So if we start talking about some different mower types, so I have a global position. As I said, AGCO is a global company. We really focus strongly on Western Europe. In Western Europe, we're getting a lot more intrigue or interest in bringing back the sickle bar mower. And so there's a lot of different rationale for that, but they have what is called, oh my goodness, I can't remember it, but it's similar to our Green New Deal over there going on that was passed. So it is in legislation over there. And so a large part of that is environmental stewardship. And so the sickle bar mower, they are claiming, has a better opportunity for environmental stewardship. So think about that as we go through this. Also with the sickle bar mower, we're going to get about 10 to 20% less cost per square foot as we're going through that field. It's going to require about half the power as what a disc mower is, but it's going to take a heck of a lot longer to go through that field than what our disc mowers are. And currently in the market in North America, I almost said the United States, but pretty much covers all of North America, our mower sales as a agricultural equipment industry as a whole are about 95% disc cutter bars. That's going to range from a pool type, from your small pool types without conditioners, 3-point hitch, all the way through our windrowers. Out of curiosity, is anybody in here running a windrower or a swather? Okay, we got a couple. All right. So that will come into play here in a little bit, and it also comes into play with the conversation that Craig and I just had about dry down time and dry down efficiency. All right, so we talked a little bit about that stand persistence and environmental stewardship, and it was really thought, or it was really a concern whenever our disc mowers came out or started becoming on the market here in the United States, that because we have the opportunity to cut so much closer to the ground, we're not going to get that same stand persistence as what we were afforded with the sickle bar mower. But what we can see here in this study by the University of Wisconsin is if we take a look, here's our sickle, here's our disc cutter bar, and if we're taking a look at the average yield in terms of tons of dry matter per acre, we really saw no difference in terms of overall yield. And this is really the important thing, is this stand persistence in their alfalfa in terms of plants per square foot. And this is a year-over-year study looking at the disc mower over and over and over versus the sickle bar mower over and over and over. So keep that in mind. Now, there are some ways that you can decimate a crop with a disc mower if you have that adjusted incorrectly. If you have that angle too low, if you're scalping the ground, and you can scalp the ground before you even realize it, that of course is going to reduce your overall stand persistence in any type of crop. But if you have that and you're still maintaining that 2.5, 3.5 inch cutting height because you have your angle of your discs tilted back a little bit, then we're really seeing no reduction in overall stand persistence. This is a little project that was supposed to happen in Europe this past year, but of course I was not allowed to travel to Europe. So we tried to do it as close to European conditions as possible. So there was really multiple different levels to this particular experiment, but what I wanted to show to you was we tried to identify some of the most common mispractices, if you will, or bad things that farmers might be doing without even realizing it in their operations. And so what we wanted to look at for the mower, and you can see we just have a little disc mower here without a conditioner on it. But what we wanted to look at was what is happening if we run this machine at different PTO speeds. So for our mowers, we're going to recommend anywhere from a 520 to a 550 RPM typically, but that doesn't mean that that's what our operators are doing. And also, what happens if we run this at different ground speeds? And so we had a heck of a time in terms of weather this week, as usual, especially as usual whenever you try to do research in hay crops. Like, yes, we have enough trouble on our farms getting our hay dried down, but then whenever you set aside a week for research, it's twice as bad. And that's exactly what happened this week, but we were able to get some data. And so we did this in Canton, New York, which is basically kissing Canada. We tried to get it as close to a European condition as possible. And we did this in August of last year, and it was so muggy but cool. I was like, this has to be exactly what it feels like in Europe. It was like 72 degrees and we were wringing wet with sweat because it was like 90% humidity. But what I want to show here is this residual after mowing. So this is in tons of dry matter per acre as we ran this mower across the field at different RPMs, at different PTO RPMs. So we ran it at 420, 520, and 620. And we wanted to look at cut quality, but if you take a look here at the amount of crop that was left in the field after we ran it at that optimal PTO speed, it really tells the story that we have to pay very, very close attention to what our PTO RPMs are as we're going across this field. Because whenever we bumped it up to 620, we left almost a ton of dry matter in the field of what should have been removed. And whenever we bumped it down, we're having those discs move slower than what they should be. And we saw about 2/3 of a ton left in the field after mowing. This made some really, really ugly cut quality. We saw a lot of ripping and tearing at the top of the grass, and we also saw a lot of grass that was just completely pushed over. We really saw no difference here in terms of ground speed. So the moral of the story is pay very, very close attention to what your RPM speed is. And you may not be running Massey Ferguson mowers, and I'm not here to give recommendations on other manufacturing types, but this is something that you can do. This was a super easy thing to conduct. Essentially, all you need to go out, take a look and see what your cutter bar height is. So, maybe this is what your cutter bar height is. So now you're going to go out and clip an area of the field and see what's left above that height. And that's how much crop you're leaving in the field. Kind of humbling, yes.
Your equipment, your recommended PTO, do you feel pretty comfortable that that's the right one?
Yes. And so that was actually one of the things that we wanted to test, because our recommendations are coming from the engineers, the guys that are building these machines. And so we were saying, okay, we're telling everyone to run anywhere from a 520 to a 550. Let's test it and make sure that this is right. And that's exactly what we did with this. We also get the question a lot about ground speed. And some of you guys may even be going faster than 9 miles an hour depending on the type of field. Some of you may be going slower than 3 miles an hour if you have a lot of groundhog holes in there. But the good thing is we really saw no effect as long as we had that PTO speed at the optimal range.
I've never seen a 520 PTO cutter. Seen a 540 or a 1000.
540? Yeah, that's fine. That's still in that recommended range.
But I mean, that's the way the equipment was set up for. So why would you want to run it at 420 or 620 when you weren't running it for the?
So a lot of times, and this is actually one of our, so we did this in conjunction with our product specialists, who are the guys that are out in the field talking to the customers. And there's misconceptions that if we run this faster, we're going to be getting a better cut quality. Or if we run this slower, we're going to be getting more of an effect of like a sickle bar mower, where it's going to be cutting much slower but a better cut quality. So that was the point in this project, was just to make sure that regardless of what your manufacturer recommendations are, to make sure that we are still remaining within those recommendations. And so this goes hand in hand with what Chris talked about a couple of minutes ago. And we're talking about respiration. And so think back or refer back to what he was talking about with the goal of getting that plant down to 20% moisture as quickly as possible. That's really the name of the game if we're making dry hay. If we're making baleage, then we're going to be getting that crop to a much higher percent moisture, or haylage, or round bale silage, or whatever we want to call it. But the goal is to get it to that targeted moisture level as quickly as possible. The longer that crop is going through respiration, the lower that quality is going. And I believe that in the afternoon session, the very last session, we're probably going to touch on that a little bit and talk a little bit about some of the opportunities to get that crop to that ideal moisture as quickly as possible. And so this is kind of showing here that targeted 20%. That's really going to be whenever we stop losing all of those valuable sugar contents due to respiration, they're going to be, reducing or being reduced in terms of being burned up. But this is really the critical time right through here, is this 80 to 60%. Whenever we're going from cutting down to that 60%, we are really losing a lot of sugars. We want that to be reduced as quickly as possible. And then whenever we're going from that 60 to 20% or 60 to 45%, if that's your goal for your round bale silage, or 50, or whatever the case may be, a lot of that is going to be dependent on your management practices. Are you conditioning? Are you laying your swath out wide and flat? What is your crop yield? And are you matching your conditioner settings to your overall crop yield? So let's go in and talk a little bit more about all of those things here in the next couple of slides. Once again, Chris showed this, so we have a lot of overlap in our slides. We probably should have consulted first, but that's okay. We'll just keep talking about it. And so essentially what we want to look at is this inverse relationship between storage losses and harvest losses. So, and down here is going to be our percent moisture when harvested, and then over here is going to be our percent overall dry matter loss. And so right here in this middle range is where we're going to recommend for your wrapped round bale silage, anywhere in that 45 to 60 to 65% moisture range. And the really cool thing is, if you take a look at this, this is going to be the best opportunity for the least amount of losses overall total. So over here in our super wet super wet forage, we're going to have tons of storage loss, lots of seepage, loss of respiration losses, probably also a lot of unfavorable microbial growth as well. And then the drier the crop that gets, the more our harvest losses are. That's no secret to anyone in this room. You have all seen the dust flying out the back end of your baler. Yes, a little bit of that is ash and soil content. A lot of that is that valuable nutrients that we were talking about in Chris's presentation, and it's flying out the back end of your baler. It's not being captured, it's not being baled. That's where a lot of these harvest losses are coming into play. This I'm going to breeze over very quickly because our hay values are going to change, but essentially what I wanted to show here was the difference in what a dry matter loss can have with, this is looking at a $239 per ton hay value, so pretty good alfalfa hay, and what the difference is in terms of loss based on the dry matter loss is going to be within your crop. So, moral of the story is reduce your losses as much as overall possible. So one of the ways that we can try and dry our crop down as quickly as possible, since we've already told you that, so we know it's important to get it to that ideal baling or chopping moisture as quickly as possible. One of the ways to do that is by using a conditioner. Typically, there's going to be two different types of conditioners. We're going to have a flail or impeller conditioner, and that's going to be what you see here at the top. Typically, this is going to be designed for grasses. But if you only have one mower conditioner and you're doing grasses and alfalfa, or in Europe, as I work quite a bit, grasses and clover, there are some machine adjustments that you can make if you have an impeller conditioner to try and conserve some of those really valuable leaves that's going to be on your forage crop. What this is going to do is create a stripping effect. So the goal of a conditioner is to somehow break that naturally occurring environmental defense that our forage crops have during a drought, or whenever they are cut, or whenever they think they're going to die. They have that waxy cuticle layer that's going to help to preserve as much moisture as possible, so we have to somehow get through that. And they also have stomatal openings. And so whenever they close those stomatal openings, that helps to reduce overall moisture loss. So we need to combat these naturally occurring things that are happening within that crop whenever it's like, oh no, I just got cut. I'm dying. What do I do? So that's really the goal of what these conditioners are doing. And so for this flail, it's going to create a stripping effect and kind of abrade the waxy cuticle of the grass. So it's going to help to kind of open that up and allow that moisture to escape that crop. However, we are going to see increased leaf loss usually if we're using this in alfalfa. For our roller conditioners, typically we're going to see this type of chevron pattern. You can get steel on steel, you can get rubber on steel, you can get rubber on rubber. It's the age-long debate of what is better, what are the benefits. Steel on steel is, of course, going to last you longer. We don't see the same wear year over year of steel on steel as what we do rubber on rubber or rubber on steel. So a lot of times we're getting the need for replacement of those rubber rolls a lot quicker than what we would a rubber on rubber. Also, we're going to talk in just a minute about how to adjust some of these different things to make sure that you're meeting your conditions needs. And with our rubber on rubber, we'll see a wider gap in the middle and a smaller gap on the sides. And so then what's happening within our crop? Only part of it's getting conditioned, and the rest of it's just flying through there like it wasn't even conditioned at all. So the goal of these should be to create a crimping action. We're going to talk a little bit about tension here in just a minute, but the goal is to break the stem or crimp the stem and not crush it. We don't want to bruise the crop. We don't want to remove any of those valuable nutrients. We want to crimp it and allow that moisture to dissipate from the stem without reducing any of the overall forage quality. So this is kind of what they look like close up. I found this illustration really valuable from one of Dr. Dan Undersander's publications. And so essentially what's happening here with the impeller type conditioner is these tines are using this hood, this conditioning hood here, to actually create that abrasion across the leaves and across the stems of the grass. And it's helping to combat that waxy cuticle. And so with our rollers, we're going to be seeing right in here is going to be where the conditioning is going to be occurring. That stem is going to be crimped. It's going to come out the back side, and I'm going to show some pictures of what it should look like here in just a minute. This is a study that was done at Penn State by actually my predecessor whenever I moved up there. And he just looked at conditioned versus not conditioned alfalfa. Very plain and simple. In the same field, he turned on the conditioners or opened up the conditioners, same mower, and took a look at what the dry down rate was going to be. And I want you to take note that at the time at which we really started seeing separation here in terms of the effects of the conditioner versus not conditioner, right around that 20 to 24 hour mark. I did another study this past summer in Wisconsin where we really saw the division right about that same time. So moral of the story is, if you go out there, 12 hours after you mow and you're like, well, dang, that stuff looks the exact same as that. It probably does. It probably is. But the goal is to get it to that lower moisture point as quickly as possible. So we talked about this right here. This 80 to 60% is really, really critical. What we're seeing with conditioning is really it's not going to have any effect in terms of getting it to that 60% any quicker. But what we're really seeing is the dry down time. We really saw a division here at this 35-hour mark in terms of conditioned versus not conditioned.
So in that last graph,
Yep.
if you're wilting for baleage, then the conditioning system has less of an impact. Is that correct?
Honestly, I think that a lot of it probably has to do with an environmental impact as well. I think that it probably has to go hand in hand together. But yeah, so if you're getting down here, it's really going to depend on what your target for baleage is going to be, I think. If you're doing it a little bit on the wetter side, the 60 to 65% range, potentially, you're not getting any benefit with the conditioner because you're still getting that same dry down rate. But especially if you're down here doing some dry hay, huge effect. This you can take a look at, but it's just taking a look at the differences in terms of dry down rates with rollers versus impellers. And this is taking a look at theoretical drying time and leaf loss, looking at our roller conditioners versus impeller conditioners. What I want to show here is this leaf loss whenever we're looking at our roller conditioners. So this is in alfalfa versus impeller conditioners. The leaves are going to be where about 2/3 of those really, really vital nutrients are found in alfalfa and even in grasses. We want to conserve the leaves as much as possible. So that's why it's really important if your only option is an impeller conditioner and you're running through alfalfa, we want to make sure that we are reducing the intensity of that conditioning just so we can try to conserve those leaves as much as possible. If you want to pull out your cell phone and take a picture of this, you're more than welcome to. I actually neglected to put this in the proceedings, and it dawned on me on my drive here yesterday that I didn't even talk about how to set your conditioners. But this is a good way to go through and make sure that the roll gap in your conditioner, so if this is taking a look at one roll, this is taking a look at another roll, is set correctly. And so what you want to do is get 3 different pieces of aluminum foil and get a pen or a pencil or a dowel or something and roll that foil around it to create a long cylinder. And what you're going to do is you'll need someone to help you so you're going to have 3 of these. You're going to take and insert that into each side of the conditioner and the center of the conditioner. Manually roll that through. Don't turn it on and try to throw it through, right? Manually roll that through. Take a look then and see what the width of your roll gap is. That isn't lying at this point because it can be really difficult to look in there and try to figure out, am I at 1/16 of an inch if that is your target? But this is actually telling the truth. What it's also telling is, do you have uneven roll gap? Are you at 1/16 in one place and 1/8 of an inch in another place? So what that's going to show is half of your windrow is going to get conditioned ideally. The other half probably isn't getting conditioned very much at all. We also talked about tension during the break. And, I did want to say one thing. I am not an AGCO employee saying this. Okay, this is off the record. But these conditioners are supposed to be set and ready to go as soon as you purchase them from the factory, right? We're supposed to have all of the settings ready for you to go from the factory. This is the common roll gap, is 1/8 of an inch. That is too wide for what we're recommending. So it's really, really important that we're making sure that we're looking at these at least once a year, at least at the beginning of the season, at least whenever you purchase the machine, to make sure, you paid the money for a conditioner. It costs more than if you have a machine that doesn't have a conditioner. You want to make sure that it's working correctly. And so if we also talk about tension on these conditioner rolls, essentially what that's showing is how easily they open up in terms of the gap. So this is going to play a part in what your crop yield is, what your crop type is, etc. The looser you have that tension, the more that roll gap has the opportunity to open up and not condition at all. So it's really important to also pay attention to make sure that you have a tight enough tension that you're actually getting that crimp in your stem. Unfortunately, I wish that I had some way of saying this is exactly the tension that you need and this is exactly how you can find it. The best way is to start mowing, get out, and look and see what your crimps look like in your stem. If you're getting a nice clean break, a nice crimp, you're probably good to go. But you also want to make sure that you're not getting leaf bruising. So in your alfalfa crop or in your grass crop, if you're looking and you're seeing a lot of oozing at the leaves, that roller is causing bruising. And that's going to be your very valuable nutrients that are going to be leaching out at that point. So just hop off the tractor and figure it out. Oh, okay, I promised a picture of a good crimp, and so here we are. So I also have to mention that at Hesston by Massey Ferguson, we have the option in our windrowers for a double conditioner. So essentially what's happening is what you see right here up in this little illustration. And so this is not available in our pull type machines at this point in time. But you can get this in our windrowers or swathers. It's very, very common in the western US because what we're seeing is these guys, they want a nice 16-foot header on their swather, but then they have a very narrow swath that they actually mow because they don't want to run over it. And we're not making the tires any wider, right? And so you're really restricted to having whether you have a 13-foot header or a 16-foot header, we're still making the same swath. And so what these guys have found is by double conditioning, so here, this is what happens if you have a single roller conditioner. You're going to get a crimp anywhere from every 3 to 4 inches. But with that double conditioner, we're getting a crimp about every 1.5 to 2 inches. So we conducted this study in Dodgeville, Wisconsin, and we tried to conduct it somewhere without ideal drying conditions because we wanted to see how does this actually work? Because, yeah, we know it's going to do fine in Arizona, right? Like, the crop's going to dry down. It's going to dry down faster if it's double conditioned. Sure, anybody can accidentally dry hay down there. What does it do in a not so ideal condition? And of course, we had the best haymaking weather of all time because we wanted terrible conditions. So anyway, this is what we looked at. We looked at no conditioner. We just opened up the rolls, ran it through single roller versus double roller, which is what we call our twin max. And we wanted to take a look at the differences in dry down rate. So this is in your handouts to look a little bit closer. Our goal was dry hay with this. So we did this on a dairy operation, like I said, in Wisconsin. He gave us a couple of acres to play around with and to collect some data on, but he definitely wanted to bale this as dry hay. So we were like, okay, good. This is really going to allow us to go through the full dry down process and get him down to some dry hay. So what we saw, once again, if you take a look here at this division in terms of dry down rates, we did start to see some division here right about the 12-hour mark. But where we really, really saw it start to separate in terms of conditioned versus not conditioned, so this top line here is just flat out no conditioning whatsoever. The other two are either single or double. We really, really saw this separation right here once again at the 24-hour mark, where we saw a very noticeable divide. But what I want to point out with this is just really a testimonial of using a conditioner in general. Yes, we did see the opportunity to bale the crop 5 to 6 hours sooner using a twin max, which if you're trying to beat a rain can really be beneficial. But I really just want to point out the testimonial of a conditioner in general. We could not get that hay dried to where the farmer wanted it to be without a conditioner. So this was actually the next morning. We baled this right here at that 52-hour mark. We had some 20% hay. We had this was like 15% hay. But then the next morning, of course, the moisture set in, the dew set in, the moisture went back up, and it was calling for rain. And the farmer was like, whatever, just bale it, bring it to the house, and we'll wrap it. And so that's exactly what we did. And I was like, well, this worked out perfectly because we were trying to show the differences in a single conditioner and a double conditioner, but we just wanted to show the benefits of a conditioner in general. And the crop that wasn't conditioned just couldn't do it. So this is taking a look at the differences in total digestible nutrients across the different collection time periods across the study. What I do want to point out is think about this in terms of percent moisture whenever you look at this. So ideally, if I had had a little bit more time, and I intended to do this before this conference, but I didn't have a chance, I should have broke this down by percent moisture and compared it. But moral of the story, what I wanted to show here was at this 52-hour mark, we saw no decline. So I wanted to show if there was a decline in forage quality with our Twin Max. Not necessarily trying to prove that forage quality was better, but I want to show that there wasn't a decline, because with double the crimping, one might think, well, does it lose more stems? What is the question? But we saw no decline in forage quality. If you take a look at these two up close, we only had less than a 1% crude protein difference. Really no difference in our relative feed value. And this is just taking a look at some cowboy math and what the benefits of using a double conditioner might be on a hay crop that's drying down in the field. Now, that was taking a look at our conditioners. The next and the next most important thing is going to be your swath width. So I talked a little bit about how in the western U.S. on our commercial hay operations, those guys want to move across the field as quickly as possible. They have thousands and thousands of acres to move across. So they have a big 16-foot header. They're running 4 or 5 windrowers in the field, but their swath is only as wide as their tires because they do not want to run over their hay for obvious reasons. So they're really seeing a lack of dry down because they're not laying that swath as wide and flat as what it should be. So instead of it being called a windrow, maybe it should be called a sunrow, because really the goal is to try and get as much sunlight on that crop as possible to try and get it dried down. And so we talked about why and why that's so important many times up to this point. But essentially what this is taking a look at is just generally what we're calling a wide swath versus a narrow swath. And I believe in this study, the wide swath was about 80% the width of the cutter bar. And really, if you're using some type of pool-type mower, that's what we're going to recommend to get the quickest dry down, is about 80%, 70 to 80% the width of your cutter bar. There's a lot of guys that are mowing in a really tight swath, and it's like 50% of their cutter bar. What's happening within that windrow, or within that swath, whatever you want to call it, is the crop is not able to, for the moisture level to get down to the point that it needs to be. And if it's really poor drying conditions, you may actually start some of that fermentation process that Chris talked about earlier, only it's going to be aerobic fermentation and not anaerobic fermentation, which is going to be what we want in our baled silage. And so we're going to really, really reduce the overall forage quality. So that's why it's important to lay that swath wide and flat and allow it to dry down as quickly as possible. And this does have a huge effect if we're doing baleage. We saw maybe a questionable effect for our conditioner. There is no questionable effect in terms of a wide, flat swath for getting that crop dried down to the ideal moisture for our baleage. So this is taking a look once again at a wide swath versus a narrow swath. If we're taking a look here at the total hours to 65% moisture, we saw a 10-hour gain by, or reduction maybe, a 10-hour reduction by laying that swath wide and flat. We saw a slight improvement in crude protein, a slight improvement in our lactic acid ratio, which Chris talked about why that's so very important. I wanted to throw this in here, and you can just look at it for fun, but we essentially did the same treatments or similar treatments to what we did for our mower project. But I added the tedder in here. Who in here is tedding their alfalfa? You're not in trouble. Raise your hand. So with tedding, there's so many different schools of thought of when to do it, and maybe we can talk about that this afternoon as well. Some people will follow the mower with the tedder and get it laid out even wider, even flatter. So the goal of what we did here was to look at different ground speeds, and our goal was to get the least variability in our wind or in our swath spread with the tedder as possible. We didn't want those chunks that sometimes come out because that's going to reduce dry down time. We wanted it flat, we wanted it smooth, we wanted it all the way across the field. We wanted 100% ground cover, right? We want it to completely cover that ground. But I do want you to think about using a tedder if your soil is very, very wet. A lot of times, allowing that swath to sit after mowing for a few hours is really going to benefit the overall dry down rate because it's going to allow the sun to help to reduce the moisture level of the soil and not just of the mowed crop. So think that through. A lot of times, if you're mowing on a dry day, it is just go ahead and ted that stuff because it's just going to go ahead and increase the dry down rate even faster. If you have a very, very wet soil, think about allowing that soil to dry down a little bit because it's going to inhibit the overall dry down rate of that crop. This is just showing the inverse relationship of ash and energy of your crop. So it has a 1-to-1 displacement ratio. And because we're talking about mowing, I felt the need to add a little bit of information in here about ash content. This is a huge inhibitor in terms of feed value or crop value or sale or whatever market price in the Western United States. And I know that a lot of you guys are probably making hay and feeding it to your own livestock and maybe making hay and selling it locally. For the export market, ash is a really, really big cost reducer. So our disc cutter bar is typically going to have higher levels of ash in the hay. We do have our mowers that are known for picking up more hay, but the reason that they're picking up more hay versus a drum mower or a sickle bar mower is because typically they're closer to the ground. And so the closer to the ground they're going to be, the more ash they're going to consume. We also did a little project in Washington looking at different rake types. I'm going to go through this just quick because this is the end, but I did want to show ash levels in terms of different rake types. So here's our wheel rake. We also had a basket rake, and then we had a rotary rake here, which really what we wanted to show was a rotary rake in alfalfa does not introduce more ash or reduce the overall forage quality versus some of these other more popular rakes. We did this in Washington. We wanted to look at those volcanic ash soils. If you ever get a chance to go out to Washington, get out of the truck, walk in a field, and take a look at what you're walking in. The soil is the same color as this ground, and your foot will sink about halfway down into it. It's like a very powdery sand, but it's very ashy. It has the potential for huge, huge amounts of ash incorporation into the crop. So we wanted to go to the ashiest place that we could go to see what is the effect of these different types of rakes on this forage quality. So we ran all three rakes at different speeds across the field. We really saw that there was no reduction in overall total digestible nutrients. That was after raking. This is after baling. Again, like a 1% change in total digestible nutrients. This is taking a look at the ash content after baling, and you all have all of these in your proceedings. That's why I'm just flying through them. You can look at them. And then what we also wanted to look at was windrow height variability. We wanted a nice, even, fluffy windrow. We didn't want a windrow that was roped, and if you have a roping of your windrow, that really inhibits the air flow between it. And so it's going to stay, if it's not ready to bale, it's going to stay high in moisture a lot longer. So we saw with our rotary rake that we actually had much more uniform and fluffy windrow. This is taking a look at our rotary rake PTO RPM differences across the field. No difference in terms of total digestible nutrient content or ash content. So we could run that rake at many, many different PTO speeds and really see no negative effect. So this is my contact information. I'd be happy to, I know that we have a whole Q&A session at the end of the day, but I'd also be happy to take this elsewhere if you need me to send you any materials or anything along the way. So very quickly, I moonlight as the executive director of the Northeast Pasture Consortium. And so I wanted to share with you our virtual conference that's coming up on March 24th. Even though it has Northeast in the title, it's really applicable to all of the Eastern United States. This is what our agenda topics are if you're interested in anything. To find more information, if you just go to Grazing Guide on Facebook, we'll have the information posted on there in terms of your registration link, or you can just send me an email and I'll get you all the information you need. Do we have time for questions? I know I went over.
Take a couple before we switch it over. Let's
Okay.
do this, guys.